So we'll do this example devote this video for this example here. So I have a toy rocket here, is launched straight up, and then the small rocket motor burns for 5 seconds and has a steady thrust of 20 newtons. And then it says, what maximum altitude does the rocket reach? So let's draw a small picture here. Solution. So our rocket starts here, starts at the ground. Let's draw it like that. So the motor thrusts in for 5 seconds. So it will give it a force this way, F thrust upward. And then, of course, there is gravity, the force of gravity downward. So the rocket accelerates and accelerates until maybe it's here at some height. Then what happens is the motor shuts down after 5 seconds. But when the motor shuts down, the rocket has some speed here. So it will continue going up until it reaches some maximum. Right? It will have a speed here until it reaches some maximum here. The speed will equal to 0, and then it starts to come down. When the motor shuts down, the thrust disappears, and the only force available will be the force of gravity at that point, force of gravity. Okay? And we will choose this to be our y direction. So we'll do it in 2 parts, because we have the force changing here, because there is the force of the thrust, and then after 5 seconds there is no force of thrust, it will be the force of gravity, and then we'll do the kinematics like that. So, while there is thrust, let us use the net force in the y direction. There is no x direction here. The x will be 0. There is no motion left and right. So the net force in the y direction will equal to the mass times the acceleration in the y direction, ay. So, this is while the motor is working. This is before the motor shuts down, okay? Before the motor shuts, before it runs out of fuel. The forces are, you get the force of thrust upward, and then minus the force of gravity because it's downward, equal to the mass times the acceleration. I'll just call it A, because that's all we have the y direction, so there is no ambiguity when I say A. Clearly I'm talking about the y direction. The thrust force is given to us, and it is, how many newtons again? 20 newtons. So this part here is 20. The force of gravity is the mass times gravity, is mg. The mass is 500 grams, so 0.5 kilograms, times 9.8 equals to ma. Again, the mass is 0.5 kilograms, and the acceleration is a. So let us find the acceleration. So the acceleration will be, let's get it. I need to use 20 minus this divided by 0.5. So 20 minus 0.5 times 9.8 is 4.9. So I get 15.1 over 0.5, so times 2. So that's 30.2 meters per second squared. 30.2 meters per second squared. So the initial velocity here is 0. After 5 seconds, where is the rocket after 5 seconds? Let me call this one here H1. H1. Or let's call it Y1. The Y1. And then here it would be Y2. That will be the final height. So Y1. I know that Y1 will equal to Y initial plus V initial times the time plus 1/2 of the acceleration times the time squared. This is not a free fall. While there is an engine, it's not negative 1/2 GT squared, because the acceleration is not gravity while it's thrusting forward. Clearly it is 30.2. So Y1 will be, well, it starts from 0 height, so that's 0. It starts at rest, so that's 0, V initial. And then plus 1/2 of 30.2 2 times the time squared, and the time is, it thrusts for 5 seconds, so 5 squared. And so you do this and multiply it by 5 squared, so let us get that. Calculator over 2 times 25, so I get 377.5. 377.5. That sounds a little too low. Maybe it's fine. 30, 15 times 25. Yeah, that's okay. That's fine. So that's that. And then let's find the speed at this point. Let me call this one here V1. V1. And then here V2 will be 0. Let me find the speed also here. V1 will be V initial plus the acceleration times the time. V initial is 0, the acceleration is 30.2 times the time, which is 5 seconds. So what do we get? 5 seconds. So 30 times 5, so that's 15.1, 151, I believe. 30.2 times 5, yeah, 151. 151 meters per second. This one is, of course, meters. All right. So now, when the engine shuts down, the only influence now is the force of gravity, and force of gravity will cause an acceleration downward. In here is negative g. There is an acceleration here of negative g. So now, for this interval going from here to here, we can use an acceleration of negative g. So we'll say, since I don't know how much time it will take it to get to here, I probably would have to use the third equation, which would say v2 squared minus v1 squared is equal to negative 2g times y2 minus y1. v2 is 0 because it will, at the very top, it would be 0. Right? When it reaches the top, it would be 0. Minus v1, which we just calculated, it's 151. 151, but I have to square it. Equals to negative 2 times g. G is 9.8. Don't put negative 9.8. I already took care of the fact that it's downward, is negative. All right? And then y2 minus y1. y1 we found is 377.5. 377.5. And so this is 0 minus something, so this is negative, but this is negative, so that just the negative goes away. So we have 151 squared is equal to 2 times 9.8 is 19.6, and the minus with the minus cancels, and here I have y2 minus 377.5, and so y2 will be 151 squared divided not by 19.6 plus 377.5. And so y2 will equal to, let's square this, divide by 19.6, and then add 377.5, and I get 1541. 1541 meters. That's about 1.5 kilometers. So that's how high it will go. And 1.5, actually I said, yeah, 1.541. Yeah, so that's how high it will go. All right, so let me make sure I didn't run out of time. Yeah, so in the next video, we'll continue with chapter 6, and hopefully we will, I'll probably need 2 more videos to finish chapter 6, and then an additional one, or maybe an additional 2 videos to do some practice problems from the end of chapter. So maybe a total of 4 more videos to finish chapter 6. That's about 2 hours, 2 more hours. Okay, I will see you in the next video.